Hello student, this is biology lesson for grade 12, prepared and presented by Mulatu Abarra. Lesson 4, Enzyme. The main content of this lesson include nature and the property of enzyme, model of enzyme action, factors that affect enzyme action. Student, at the end of this lesson, you will be able to define property of enzyme, explain model of enzyme action to lower activation energy, and again discuss on factors that affect enzyme action. Student, do you know what enzyme means? What is the function of enzyme? Well, all enzymes are a complex globular protein with unique tertiary structure that is used to speed up chemical reaction in living organisms. Here, enzymes are a complex globular protein with unique tertiary structure that is used to speed up chemical reaction in living organisms. As we have seen in our last lesson, enzymes are a protein. And again, the unique three-dimensional shape of enzyme allows them to specifically catalyze substrate. That is very important for the reaction to takes place. So, why enzyme is specific? What do you think the factors that beyond to make enzyme are specific? Well, within a complex structure of enzyme, there is active site. The shape of active site or three-dimensional structure of active site allows them specifically to specific substrates. So, what makes enzyme to become specifically catalyze specific chemical reaction is because of the shape of active site. For example here, let's say this one is an enzyme. When it's this enzyme, there is active site. The shape of this three-dimensional structure of active site allows them to become specifically bind with that of specific substrate. For example, enzymes that catalyze sucrose to hydrolyze that of respective monomer can be catalyzed by sucrose. No other enzyme can be act over that of sucrose. Only enzymes that catalyze maltose can be only catalyzed. For example, here, let's say there is maltose. Only enzyme maltase can be active here. Maltase. Enzymes are specific because of their shape. No enzyme can be catalyzed two or more chemical reactions. Because they can specifically bind together, enzyme substrate complex can be formed here. Well, enzyme, as it is organic molecule, it has so many properties. One is, it is globular protein with three-dimensional conformation. And again, when enzyme binds with certain chemical reaction, it can lower a minimum energy that is required to start chemical reaction, activation energy, lowering of activation energy when enzyme binds with that of certain substrate. And again, enzymes are specifically catalyze certain specific reaction only, which means specific one enzyme can be react with one substrate only. The else, enzymes are very effective in small amount, which means a small amount of enzyme can be brings to large change of chemical reaction. Else, enzyme can be unaltered. When we say, if we add enzyme to that of certain reaction to be carried out, speed up the rate of the reaction, we can take it again for another reaction. It can be used over and over. Enzyme cannot be altered at the end of the reaction. The else is, enzyme may be affected by so many factors, just like that of pH, just like that of a heat, just like that of another substance, the one that we call inhibitor. These are some property of enzyme. When enzyme catalyzes certain chemical reaction, as a result of catalysis, the following may not be changed. 1. Enzyme cannot be affect the type of product formed. The only target of enzyme is to speed up the rate. Again, the nature of the catalyst itself cannot be changed, may not be unaltered here. And again, enzyme cannot be changed the course of the reaction or the direction of the reaction. It cannot change equilibrium of the reaction here. This is what cannot be changed during enzyme substrate complex formation. The only target of enzyme is specifically catalyze substrate to lower activation energy to speed the rate of chemical reaction. Enzyme is very important in metabolism, in speed upping the sum total of reactions that takes place in the life. Student, it doesn't mean that no chemical reaction cannot be takes place in absence of enzyme. Reaction can be takes place in absence of enzyme, but the rate becomes slow. The main aim of enzyme here is to speed up the rate. So here, they can speed up the reaction. For example, the reaction between substrate A and that of B to form a product B. It can be takes place alone in absence of enzyme. But here, if enzyme added together, the rate may be faster than that of if it is no in absence of enzyme. So here, it forms AB product plus enzyme. Enzyme cannot be changed at the end of the reaction. Enzyme cannot be affect direction of the reaction. Enzyme by itself cannot be changed. The type of the product cannot be changed. The only thing is they can speed up the rate by lowering activation energy. Speed up the rate by lowering activation energy. So, when enzyme added to that of certain substrate, specifically, they can easily climb an activation energy hill easily. Which I mean, let's say, the reaction, which is this one is said to be an catalyzed reaction. No enzyme is added here. Amount of activation energy is higher here than that of amount of activation energy for catalyst. Amount of activation energy here is high, and again the speed is high. And again low activation energy. The main difference is here. Low speed for uncatalyzed reaction, and again high activation energy. For catalyzed reaction, but there is high speed with that of low activation energy. There is activation energy difference created here. If enzyme react with that of the substrate, they can lower activation energy. They can easily climb this transition state here. There is a transition state. Activation energy here. No product changing. The same product, the same course, but the only thing is reduction of activation energy. The only thing here is again the speed. So enzyme is very important over that of speed plus activation energy. So there are two main models that are indicating how enzyme binding with that of certain substrate can be lower activation energy. Those two speak that enzyme binding with substrate lower activation energy. The main difference is how enzyme binding with the substrate can lower activation energy. The first model of enzyme action is lock in the key model. According to the principle of lock in the key model, the shape of enzyme is complementary to that of an enzyme active site. There are complementary shape binding here. They assume that this complementary enzyme substrate binding forms enzyme substrate complex formation that can allow the reactant to become enter into that of transition state, lowering activation energy. Simply complementary substrate active site binding lower activation energy. They simply allow to become jump to that of activation energy hill or transition states. For example, here there is intermediate format here. There is reactant A, reactant B plus enzyme, which we call catalyst. Catalyst pathway it is. There is intermediate, which we call a part of a pathway here, a part of transition state. There is product formed here, product AB. Enzyme is unaltered and found as it is here. So here, this model sees that enzyme substrate complex as an intermediate, which is a part of pathway, require less energy or less activation energy than that of the normal pathway. Normal pathway, which is uncatalyzed one. The main thing is enzyme substrate binding lower activation energy. The great weakness of this model is they didn't understand how they can lower activation energy, how activation energy can be lowered, how intermediate have a lower activation energy than that of the normal pathway. For example, here, the shape of, accordingly, the shape of substrate in the enzyme become binds like the shape of an egg that is complementary fit with that of its shell, or the shape of key that it fit with that of its lock. You cannot open one lock by another key. The same is true. One enzyme can be capable to open one substrate. This complementarity can be reduced activation energy. Another model is induced feed model. This is very important in the widely accepted models as that of lock and key model. This model suggests that enzyme substrate binding is not complementary, but the binding of substrate brings to that of a conformational changes to the shape of active site. These conformational changes allow active site enzyme to become bind fully. Conformational changes a reason for that of binding of enzyme in the substrate to become bind fully to form enzyme substrate complex. Enzyme substrate complex here. So here, this conformational changes that bring substrate to become immersed into that of tension. So here, substrate bringing under tension that allow the reaction to become easily enter into that of a transition state or intermediate. There is jumping of activation energy here easily if substrate become entered into that of tension. So there is kinetic energy increasement found here. With this one, activation energy become lowered. This model is to become preferable over that of lock and key model because of the following reason. One, they are able to define or explain another property of enzyme, like enzyme can be inhibited by another factor. Another, they can capable to understand enzyme controlled reaction, the rate at which reactant convert to that of product. And again, how many substrate molecule can be bind to that of enzyme molecule to form enzyme substrate complex per second, which is determining about that of turnover rate of an enzyme. The rate at which substrate bind with enzyme to become transferred to that of the product. Turnover rate, speed determination, factor determination. Let's have this diagram. Here, there is substrate, there is enzyme. The only thing that reduce activation energy is not their complementarily bounding. They are not complementary. The main thing is the binding of enzyme in the substrate brings active site into that of a tension. that brings change into that of a shape of active site, that brings substrate under retention, which is a reason for that of enzyme substrate complex formation, which is come to enter into that of a new pathway. With this tension, with immersion of substrate under retention, they can lower activation energy. So they overcome the limitation of lock in the key model that induced feed model is very preferable. Well done. Enzyme, as it is protein, it can affected by so many factors. There are so many factors that affect rate of an enzyme action. The first most important factor that determines the rate of enzyme action is temperature. Obviously, the rate of the reaction increases with a temperature until an optimum temperature. Optimum temperature to mean a temperature at which body enzyme of an organism properly work. If temperature increase, the rate of enzyme action become increased together. If temperature increase, the rate become increased together. If temperature increases beyond the optimum condition, the rate may not be increased. So, a body temperature of an enzyme contain an optimum at which they can properly work. So here, temperature increases the rate of enzyme action because it increases kinetic energy of the molecule. When temperature increases, molecules substrate become collide together more energetically, more rapidly. Then enzyme substrate complex become easily formed. But if temperature become increases beyond or above this one, above optimum temperature, rather than increase the rate, it is come to break the bond that holds three-dimensional structure of enzyme. Since enzyme is tertiary structure with three-dimensional structure, they can catalyze. But if they lose this three-dimensional structure, they cannot be catalyzed. At this point, no enzyme substrate complex formed. At this time, reaction rate is come to 0. So this one is a graph that is going to indicate how temperature can be affect the rate of reaction. Hint, student, all organisms can have their own optimum body temperature at which their body enzyme can be properly work. Another factor that affect enzyme action is pH. pH also affects the rate of the reaction, the rate at which enzyme substrate complex become formed. Here, as pH become increase or that of pH become decrease, the nature of charges, the nature of amine, and the nature of acidic part become affected. We have seen as protein contain carboxyl in that of amine group, the charge over that of amine, the charge over that of carboxyl become affected. If the charge affected, enzyme may not be no more catalyzing, no more speeding the rate of the reaction. Most mammalian pH work at this pH, at neutral one, the one that ranges between 6 to that of 8. Their body enzyme properly works at this neutral pH. Enzyme may be affect the rate of the reaction in the following two main activity. One, by breaking the ionic bond that hold tertiary structure together. This ionic bond contain positive R side chain and again negative R side chain. By breaking the bond that holds them together, enzyme no more catalyzing the reaction. If the bond that holds them become breakdown, enzyme become going to denatured. Upon denaturation, there is no more catalysis. There is no more speed up the rate of the reaction. Another, they can alter the charge over that of the active site. If the charge of active site become altered, it is too difficult for enzyme to bind to that of specific substrate. By that, pH is another factor, another most important factor that affects the rate of the reaction, the rate of enzyme substrate complex formation. So, all organisms can have their own body pH at which their body enzyme properly works. For example, the optimum pH at which pepsin works, the optimum pH at which trypsin works, around 6 to that of 7, around 2 to that of 3. So, the body, all enzymes can have their optimum pH at which they can properly work, unless they can bring to that of denaturation, unless they can bring to that of charge alteration. This is another factor. The other factor that can affect the rate of the reaction is substrate concentration. Student, we have seen a substrate is the substance upon which an enzyme binds with. So, enzyme activity highly depends on the substrate molecule to form enzyme substrate complex per second. This means the rate of the reaction increases with a substrate concentration. Means if substrate concentration become increases, more collision between substrate enzyme takes place. More enzyme substrate complex going to form it. That can work at maximum turnover rate. The rate conversion of reactant to that of the product. So, if there is low substrate concentration, the rate of the reaction become low. Low collision between that of substrate and that of enzyme, and again low rate of enzyme substrate complex formation. If substrate concentration become increases beyond the maximum point at which they can work, it has no meaning. No more increasing the rate of the reaction. It has no effect over that of enzyme activity. Increasing substrate concentration above the maximum point at which the rate can be takes place, it has no effect. Because the whole space of active site is totally occupied, totally used up. Saturation point is become arrived. So, with substrate concentration, rate of the reaction become increased. Until what? Until the whole space of active site is fully saturated, fully used or that of occupied. Let's show this diagram. If this one is a rate of reaction, this one is substrate concentration, binding of substrate with that of enzyme increases the rate until the whole shape of active site get saturated. The whole shape of active site. If the whole shape of active site occupied, adding of more substrate has no effect over activity of an enzyme. It is going to saturate it. Student, we have seen enzyme and the some property of enzyme. We have seen again how enzyme can be speed up the rate of chemical reaction and the some model of explanation, the difference between low-key model and that of induced defeat model, and how they can explain reduction of activation energy. Additionally, we have seen factors that can affect the rate of chemical reaction, just like that of temperature, just like that of pH, and again substrate concentration. In our coming lesson, we will see other substances that affect the rate of chemical reaction. Until that, bye.